Окей, хорошо. Давайте тогда по-английски. Ну, то есть, если вы хотите, то, ну, то есть вы выбираете. Вот. Так, окей. Let's check some problems from your home assignment. Which one?
25, 12, 13.
25.12 and 25.
Well, 13 and 14. So 3 tasks.
Okay. Let's check 25.12. Okay, what is given? We know that we have a random variable x. It is the time of we have 20 as far 20 light bulbs, yeah, 20 I will denote an old style lamp, yeah, light bulb. Okay, we have 20 light bulbs, and let's denote x1, x2, x3, x20. The time of life for each light bulb. Okay.
Yeah.
So x1 is lifetime of first light bulb. X2 is the lifetime of the second light bulb, and so on. Okay. We have x1, x2, x3, x20. And we suppose that we have 20 light bulbs and their lifetime is are independent. That's maybe realistic or not realistic assumption. So, for example, if they are in the same building, that's not a realistic assumption, because in the case of jump in the voltage, every lamp will go off probably. Okay. So, but we will suppose that maybe they are in different buildings. Okay, so we suppose that these variables are independent, and it's also given that the time x has exponential distribution with unknown parameter lambda, and we know that expected value of each lifetime is theta. Okay, so it's given. And let's denote by, maybe I will denote by m, not by x, to make it more. So m will be the minimal time, minimum lifetime. So I observe the first light bulb that goes off. Okay, so I wait until I observe the first dead light bulb. Okay, so if I draw timeline, so this is t, and if I draw, this is the first light bulb, number 1. So it leaves and it goes off. This is x1, the lifetime of the first light bulb. I have the second light bulb number 2, and it has, let's say, it has lower lifetime, x2. It happens to die earlier than the first one. Let's say I will draw 3 light bulbs, not 20. I'm lazy. And the third one is here, x3. x1, x2, and x3 are random variables, and the m, in this case, m is the first, the lowest, the shortest lifetime. Okay? Yeah. And our question is, in exercise, we have to build theta hat to build theta hat, and we know only m. So we need to build a function f of m, and we need to find a function of m, such that the estimator is unbiased. Yeah? The question is how to build an estimator of theta using m, and the only requirement that estimator is unbiased. This is our requirement. The estimator should be unbiased. Okay. What does it mean, unbiased estimator?
Expected value equal to theta.
Okay, yeah. Unbiased estimator means expected value of theta hat is equal to theta. Okay. But we don't know theta hat yet. Okay, it's some function of m. Okay, we don't know the function. So what to do? Let's for the moment calculate expected value of m. Maybe it will give us some hints. Okay, so let's calculate expected value. So we don't know how to calculate it because f is unknown function. So we cannot calculate expected value of f of m. I don't know how, because f, I don't know, maybe it's m squared or m cubed or cosine of m or 1 over m or m times 5. I don't know what is this function. Okay? So I need to find such a function that expected value of f of m is theta. Okay? So for the moment, let's find the expected value of m. Let's try maybe the simplest function, m itself. Okay, let's try a blind guess. So first, what I know about exponential distribution. Let's recall some basic facts about exponential distribution. What is the density f of xi at let's say t? What is the density function? Who remembers the density function, probability density function of exponential distribution?
Lambda.
Yeah, it's lambda times e times exponential. Yeah.
Minus lambda x.
Lambda t. So x is a random variable, t is a point wherever, or 0. T less than 0, t is greater than 0. So the density function, so this is t, this is density function, is negative, is 0 in the negative, half for negative t, this is f of t. And it goes something like this. Lambda is a known parameter. Theta is also a known parameter. But in our case, these two parameters are linked in a very easy way. We know from, if you have passed previous probability exam, maybe you know what is expected value for exponential distribution with a parameter with rate. This is called rate of exponential distribution. What is expected value of x?
1 divided by lambda.
Yeah, 1 divided by lambda. Yeah. Rate events per, let's say, per hour. Yeah. Expected number of events per hour, and this is expected time before first event. Okay, yeah, we know that it's 1 over lambda. Okay. So let's try to find, so we know the density of each xy. We know the density of x1, we know the density of x2, we know the density of x3, and so on. Okay? Yeah. Let's find the density of we know the density of each x, of x1, of x2, of x3, it is. And we have another random variable m. which is a minimal value of x1, x20, and let's find the density of m. Yeah, let's find the density of m. What is the density? We know that. Okay, so I will give you some questions that are maybe very easy. What is the probability that x1 is greater than some t, or maybe some u? What is the probability that x1 is greater than some u? How to imagine that u is positive, u is some positive number. How to calculate this probability? Integral from
0 to...
not 0. x1 should be greater than u. So x1 should be greater than u.
U.
So which integral?
From u.
U to...
From u to...
Infinity.
Yeah, let's look at this plot. To what?
Infinity.
To plus infinity. And what should I integrate?
This function.
Density function. Okay, what is the density function? It's lambda c minus lambda t dt. So integrate it. Find the integral. Do the work. Because no one will do the work for you on the exam. At home, yeah, maybe. You can find your favorite cat, dog, name, right? And my lovely cat, could you do the home assignment for me?
Okay, welcome.
Okay?
Yeah.
Let's. Okay, who has done?
I have.
And what is the
Yeah.
answer? Just no one will do the integral.
Exponent.
Exponent in u and minus lambda t
Exponent
minus lambda and u
times plus
Tam-
what?
times u.
Times u. Okay. Yeah? Ike, do you agree? Misha? That's fine? Because let's just take the integral. If you cannot, so... Okay. Let's continue. And what is the probability that x2 is greater than u?
The same?
The same. Why?
Because
They have the same distribution.
They have the same distribution. Yeah. Okay, so let's go back to m. What is the probability that m is greater than u? What is the probability that m is greater than u?
is the least one
Means
maybe?
that the minimum
Yeah.
is greater.
But if the minimum is greater than u, then each x is greater than u. If the smallest x is greater than u, then that means every x is greater than u. x1 is greater. So if minimum is greater than u, that means first x is greater than u, second x is greater than u, okay?
Yeah.
So if minimum m is greater than, that means first x is greater than u, second x is greater than u, third x is greater than u, because otherwise, if at least one x is not greater than u, then minimum x will not be greater than u. Okay, but if every x is greater than u, we know that x1, x2, x3 are independent. So if they are independent, then probability that every x is greater than u can be obtained by using multiplication, because this event A, this is event B, this is event C, this is event scientist letter. Okay, so these events are independent, so I may replace the probability of simultaneous occurrence of all these events by product of probabilities. Okay? So I just multiply probability x1 greater than u times probability x2 greater than u times probability x20 greater than u. Okay? So if I multiply 20 such terms, I will obtain, if I multiply 20 terms like this, I have 20 terms like this, what shall I obtain?
Minus 20 times.
Yeah, I will obtain exponent minus 20 lambda u. Okay?
Yeah.
Now, my goal is to find, do you remember fm of, let's say, u? Yeah? The density function for the random variable m, not for x1, but for m. Okay? From this function, I may easily go to cumulative distribution function. Yeah? I can easily find big F of m at u. That is the probability that m is less or equal to u. Okay? How can I find this function if I have already found the function that probability m is greater than u? How can I easily find probability that m is less or equal to u?
1 minus.
Probability that m is
1 minus probability that m is greater than u, so it's 1 minus e minus 20 lambda u. Okay? Yeah. So, and what is density function for m random variable? This is big M and small u. How can I calculate the density function? If you are very careful, you should remark that this works only for positive u. Okay, this is for u greater than 0 and 0 for u less than 0. Okay, you may add the... Okay, how may we calculate? This is cumulative distribution function, функция распределения, cumulative distribution function. This is density function, функция плотности, density,
Yeah.
плотность. This is cumulative distribution function, распределение. Okay, what is the density if you know the distribution function?
derivative.
Yeah, and what will happen? With respect to lambda, with respect to u?
We will have
Or with respect to
20
e?
20
times
lambda.
lambda times.
Okay, yeah, I agree. That is df, d big F, du, because lambda is a parameter. It's not a point. Okay? So df du, and I have 20 lambdas times O0, 20 lambdas times e minus 20 lambdas times u for u greater than 0, and this is for u less than 0. Okay? Now, we know the density function of m, and we can easily recognize this function. If you look carefully at this density function, you may say, oh, m is has which distribution?
Exponential.
Once again, exponential distribution, because we have something. So if you consider exponential with rate equal to lambda, then you have f. So if you have some variable y that is exponential with rate lambda, then density function is lambda times e minus lambda y. Okay? In this case, a rate is equal to what?
20 times. Yeah.
To 20 lambdas. Okay? Lambda is the rate for x1, lambda is the rate for x2, lambda is the rate for x3, but m is exponential with rate 20 lambdas. So m is exponential with rate equal to 20 lambdas. Okay? Rate по-русски интенсивность. Интенсивность. Intensity. Okay, so expected value of m is
20 lambdas.
no.
One
What is
divided by
expected
one
values
divided
for
by
exponential variable? It's 1 over rate. In this case, it's 1 over 20 lambdas. Okay?
Yeah.
And we'd like our parameter of interest, theta, our parameter of interest. Our parameter of interest. If you remember, theta is equal to what?
expected value of
Yeah,
x.
expected value of x1, expected value of lifetime of any light bulb, and it's 1 over lambda. Okay?
Yeah.
So we have proven, using some basic integration, we have proven that expected value of m is not theta, it's theta over 20. Okay? And so basically, if on average m, what we observe, so we wait until the first light bulb goes off. So we wait, oops, this goes off. And we record the time m. Okay, if expected value of m is theta over 20, and we'd like to construct unbiased estimator, then how can we construct unbiased estimator? So which function of m should we take? Maybe. So some function of m, and we need expected value of theta hat equal to theta.
20
20.
times
20.
20 times
m.
m, yeah. The good function theta equals to 20 times m. And obviously, if you know that expected value of m is theta over 20, then expected value of theta, in our case, it's expected value of 20m, it's 20 times theta over 20, it's theta. Okay? So we have created a function of, so what is an estimator? Estimator is a function of what we observe. We cannot something say like, I would take the true value of theta as estimator. That's not good. Why?
We cannot observe.
Yeah, we cannot observe it. That's the problem. Because otherwise, expected value of theta is expected value of theta is theta because it's a constant. So, but we cannot do like this. We do not observe this unknown parameter. It's unknown parameter, so we cannot do like this. We can use only what we observe in a formula for estimator. Okay? When we estimate something, we can, what we observe? We observe x1, x2, x3, or more exactly, we observe the first one. We observe m. Okay?
Yeah.
Okay, so we have done this exercise. So we can check whether this estimator is consistent or not consistent. Состоятельный, consistent means состоятельный. We can check that, for example. So, can we check that it's consistent?
Now, for example, in 25.14, we need to check the consistency.
Okay,
So we
let's
have
do.
time.
Okay, let's do. I think. Can we check easily consistency here? Okay, let's do next exercise, and I will think whether we can check consistency easily here, because yes, we can check, but that's not so obvious. think we can. Okay, let's check consistency because it's a good idea. We have unbiased estimator, but let's check consistency. Yeah, let's check consistency. Consistency, состоятельность. Let's check because that's a good idea.
We need to find the limit of.
Yeah, we need to find probability limit. Yeah, we need to find probability limit. Okay, let's try to do this. Okay, first let's see that we have first when you check consistency, you need a sequence of estimators. You cannot check consistency of that one estimator. We check consistency of a sequence. Okay. Mm-hmm. So what is theta 1? What is theta hat 2? So first we need a sequence. We cannot check consistency of a particular random variable. We check consistency of a sequence of estimator. So in this case, the first is just, let's say, x1. The second is 2 times minimum x1, x2. Third estimator is 3 times minimum of x1, x2, x3. Okay? So basic idea, first we need to understand that consistency is a property of a sequence of estimator, not of a particular estimator. We can check whether a particular estimator is unbiased for 20. For 20, this one is unbiased. But to check consistency, we need a general formula that depends on n. In our case, it will be obviously n times minimum of x1, x2, xn. Okay? Yeah? Mm-hmm. So this is a general formula, n times minimum of x1, x2, x3, xn. So let's find the density function of this random variable. Okay? To understand whether it's consistent, let's check the density function. Okay. What is the density function of minimum? Okay. Let's introduce explicit letter m. So m number n. Okay. I will add explicitly because in previous point when we check unbiasedness, we check for particular value 20. But when we check consistency, we need general formula. Okay? So first, this is minimum of x1, xn. So what is the density function of mn? That's easy. We have calculated the density function for m20. Now we need a general formula for density function of n number n.
Multiplied lambda.
Yeah.
E minus n lambda.
Yeah. N multiplied by lambda times
E
exponent
minus n multiplied u.
Sorry, u. Okay. Yeah. Okay. This is for positive u or non-negative and 0 for negative u. Okay. This is the density function. Okay. How the density function changes when I multiply the density, the random variable by a constant. So what happens with the density function when I multiply a random variable by a constant? It's a good question because it's, if you understand, it's
it decreases faster. It decreases faster, but
no. I fix n and I multiply by n. So my question is very easy. So my question is like test level. So on the final exam, you will have a test with roughly 30 questions, and that's I think test level. It's not a very hard problem. So my question is so imagine this is the imagine this is 0. Let's say 5. Let's say. This is so my small question. So this is 2.5. 2.5. So my first question. This is u. This is f of u. So first, what is this number? you know that this is a density function of some random variable, I don't know, z. This is a density function for random variable z. My first question, what is, so I have two questions. First question, what is this number?
Maximum.
What is the number? And the second question B, draw the density of W that is equal 3 times Z. So my first question, what is this number, the highest level of density function? And second question, how the density function changes when you multiply it by constant. The random variable. You multiply the random variable by constant. How the density function changes. So first question, what is this number? And second question, draw the density for 3 times Z.
4.
So first question, what are the basic properties of density function? What is the total area under any density function?
The square.
What is the total area under the density function?
The square
It's
must
1. It's always 1. The total area under any density function should be 1.
Yeah.
Okay. So we know that this area is 1. Okay. But I have two triangles. If I pick up this triangle and move it here, if I cut the left triangle and I move it here, I will obtain a rectangle. Okay? This side is 2.5. To make area equal to 1 without any integrals, I can say that this side of a rectangle, should be 1 over. So if this side, I have cut this triangle and I put it there. So these two triangles are equal.
1 over 2.5?
Yeah. The area of this big blue triangle is the same as the area of this rectangle.
Yeah.
But this rectangle has one side 2.5. The total area should be 1, so the other side should be
2,
Let us count.
this side is 2.5. The total area is 1. Area 1 equals 2.5 times other side. So other side
0.4.
Other side is 1 over 2.5 is
0.4.
2 over 5, 0.4.
2 пятых, я не прав?
Мне послушай.
2 fifths.
2 fifths, okay.
С самого начала.
Okay. Okay, this is the density function of which random variable? Of Z. And now let's consider another random variable, W. Z can take any value from 0 to 5. And what are the possible values for random variable Z? For random variable W, sorry. If W is 3 times Z, how the density function changes when we multiply a random variable by a constant 3? For Z, what values are possible? From 0 to 5. What values are possible for W?
From 0 to 15.
From 0 to 15. So draw the density for W. So draw a separate picture for W. Draw the density you have, I don't know. On the text you may have such a question. Choose the density or write the formula, choose the formula for the density function of W, because it's a good question. It's easy if you understand what happens. But because here's the only thing we need is to multiply by n. So we will just multiply by n. Not by 3, but by n, and that will be our final answer. and we can check whether the estimator is consistent or not. So who has drawn the density function of W?
Like 215 will be the length of this.
So we should replace 5 by
15
15.
will be 215.
We should replace 2 over 5 by
3.
yeah, because if you just change the horizontal scale, you will increase the area.
It will be more than 1.
Yeah, the total area under the curve will be more than 1. So you need, when the random variable is multiplied, 2 things happens. First thing, the horizontal values for possible values are increased by a factor of 3, but vertical probability density is decreased by 3. Otherwise, the total area will change, and we don't want to change the total area. It is always 1 for density curves. Okay, so the answer, the density for W goes from 0, 15, this is 7.5, and this is 2 over 15. Okay? So this is the density for random variable W. Okay? So when we multiply, so what happens? When we multiply the random variable by a constant, so f of c times y at u is equal to what? Let's say c will be small. So what happens? Who can tell me if I have f of u, so any function, what happens? I should divide by 3, so it 1 over 3 times. How to encode the horizontal dilation? What we should do? F, that should we multiply or divide here?
Divide.
So to delate a function, we should multiply inside or delate. Sorry, multiply or divide. So if you have, I don't know, cosine of u, what happens if you take cosine of 2u, and what happens when you take cosine of u over 2, of 3u and u over 3? What happens with cosine of 3u? It's dilated or contracted?
Contracted.
So if you consider arrangement like this, that one is like this or like that. So it's contracted or dilated. So if you
The second one is
yeah, 3 times 2 is that one. And if you divide it by 3, you will have a slower. Okay. You can check whether the period. So how much? So you need to add 6 pi to change the argument by 2 pi, and here you need to 2 pi over 3 to add. Okay, so to delete it, we need to take something like u over 3. Okay? So when you multiply, w is 3 times y, or sorry, 3 times z. Okay, we need to do 2 things. Delete by horizontal on the horizontal x and contract on vertical x. Okay? Now let's go on. We know the density function of m. Yeah? And how theta is related to m? How theta hat is related to m?
N
N times, okay?
Yeah.
So, we can say that theta hat is n times mn. We know the density for m, so we can calculate the density for theta hat. Okay?
Mhm.
What is the density for theta hat? The density for theta hat. So we need to take this function and we need to divide outside, yeah, and inside. Okay, we divide by n. Okay, we divide by n here and we divide by n 2 times. Okay, so what we will obtain? We will obtain lambda times e minus lambda u 0 for positive u or negative u. Okay, this is the density function of theta hat. And now we can see, we can check the consistency. So what have we obtained? This is u. This is the density function of our estimator. And the density function of our estimator is like this. And we see that our density function of our estimator does not depend on n. So there are no n here. So if you use just one light bulb, if you use the data on the first between 7 light bulbs, if you use the data on the shortest lifespan among 100 light bulbs, you have the same density. The same density. And so we see, so this is a true parameter theta. And so we see that probability that theta hat deviates from theta greater than epsilon. So this is the probability, theta minus epsilon, theta plus epsilon. It means probability. This probability doesn't go to 0 with n increasing. So we see that for every n, the density function of theta hat is the same. Okay? The density function is for every n is the same. So the probability of making error greater than epsilon does not go to 0. And so our theta hat is consistent or not?
Not consistent.
Not consistent. Not consistent. That was not in the homework because it's a hard question. But anyway, we can check consistency in this.
I'm sorry, but if we have n around the eternity, that means that they need to divide our function, density function over eternity, and we will have something.
No, we never divide by, when we calculate limit, we go step by step. So for we have no such number as infinity. We see what happens when you increase n. We don't plug in n equal to infinity because n is a number. So we just check whether it approaches when you increase n.
Yeah.
Because your intuition will fail what happens when you plug in infinity here and infinity there. So we're not plugging in infinity. We just check what happens when n increases. And we see nothing happens. The function stays the same for every n. For n equal to 1, for n equal to 2, for n equal to 100, it's the same function. So we calculate for every specific n, for every finite n, we calculate this probability. From geometrical viewpoint, this will be the density probability that theta hat deviates from theta greater than epsilon. So, this probability is shaded. Okay? And I see that this shaded probability does not decrease when n goes bigger and bigger. Okay? So I'm not working with infinity. I just say, let's take particular value of n. Let's increase it by 1. Nothing changes. The probability is constant. Let's increase it by 1. Nothing changes. So when I increase up to infinity, nothing changes. The probability of making error will not decrease. Okay?
Yeah.
Okay, let's move on. Let's make 25, 13, yeah? 14 or 13?
14, I think.
14.
More interesting.
Okay, I will just switch on my laptop and look. 14, yeah?
Yeah.
Okay. Let's consider.
Is it the same E also like epsilon is exactly?
Sorry?
They are not the same figures in the first and the second line. Are they the same or not?
Who?
Like expected.
Epsilon.
expected.
Yeah, epsilon. Yeah, we need to make them the same. Yeah, I will update this. So what do we know? We know that, let's say, you solve probability problems each day. Imagine Sonia, so 25.13. So imagine Sonia solves probability problems every day. Okay? And to solve probability problems, Sonia drinks, what do you think?
Water.
Water, yeah. So you have some data. So you have probability problems. So this will be X, and this is Y. So this will be cups of water. So now this is actual data. So X we consider as non-random. Non-random. For example, Sonia does 25 probability problems every day, and on weekends Sonia does 50 probability problems. Okay? Yeah?
Yep.
Sonia solves 25 probability problems every day, but on weekends 50 probability problems. Okay? So and that goes on forever. 25 boring probability problems every day, 50 boring probability problems at weekends. Okay? Yeah. And the number of cups of water, so this is non-random sequence. X are non-random. Y is unknown parameter beta times X plus some epsilon. So Sonia needs water to solve probability problems. Okay? So the number of cups of water that Sonia drinks depends on the number of probability problems solved plus some random noise. Okay? Yeah? Okay? So once again, X are non-random and Y are random. Y1, Y2, Y3, Y4, they are random. Why? Y1, Y2, Y3 are random because of which term? What is random in this formula?
Epsilon.
Yeah. This is non-random. And this is random. Okay. And we have two estimators. We have beta 1 hat, which is equal to y bar divided over x bar. Okay. And we have beta 2 hat, that is sum of xi times yy divided over sum of xy squared. Y ranges from 1 to n. Okay. And what we need to check? We need to check. What do we need to check? First, we need to check unbiasedness. Unbiased. So my first advice is when you have difficulties, write not the sum sign, but plus, dots, plus. So my advice is when you need to check something with sum, my advice first, if you can do this with the sum sign, that's perfect, that's okay. But if you can't, my advice is first, replace sum with A1 plus A2 plus plus AN. That is the first advice. If that does not work, then my second advice is take n equal to 3. So my first advice, if you cannot work with this expression, then replace sum by actual plus and dots. If you cannot, then simplify. Take n equal to 3 and you will be happy. Okay? So, Grisha, давай попробуем. Let's try. Calculate expected value of beta 1 hat, calculate expected value of beta 2 hat, and check whether they are unbiased. I believe in you. You are a strong man. You can do this.
So we're looking for expected value of beta 1?
Yeah. Yeah, we observe everything. We observe x.
And
they are
so
both observable.
It's constant, kind of.
Yeah, they are non-random. Yeah, okay. Because the constant in any language has two meanings. First is a non-random. Second, that is constant in time. In time, it's not constant. Yeah, it varies in time. Okay, but it's not random. We can perfectly predict what would be the next value. Okay. Okay.
Should we? So is it clear that y1, y1, y2, y3 that they are independent due to?
Yeah. Because these are constant, and epsilon 1, epsilon 2, epsilon 3, and so on are independent.
Expected value of y lines n multiplied.
No. Let's better just plug in. So be honest. Write. What is y bar?
Expected value of y1 plus y2 plus yn divided by n.
Okay, yeah.
So these variables are independent.
Okay, yeah.
Because epsilon y is a random variable. And they are the same, so we can write only the expected value of y1.
No, they are not the same. They are not the same. Be careful. So I strongly advise you to work with n equal to 3. So if you think they are independent, work with n equal to 3. Just work with n equal to 3, and you will see that they are not independent. Not the same. You cannot just multiply. So let's do it like this. So what is expected value of y1? What is expected value of y1?
B multiplied by x1.
Yeah, it's b multiplied by x1 plus 0. What is expected value of y2?
B multiplied x2.
Yeah, they're different. You cannot replace by 3 times x1. No. What is the expected value of epsilon? The expected value of epsilon is... Which expected value of epsilon is 0. Variance of epsilon is 1. Epsilon are independent. So we know about...
0.
Yeah, okay.
Plus b multiplied x2 plus b multiplied by x3.
Okay, but you forgot to divide. No, okay. Yeah, and now let's simplify.
3 times xy
Okay,
multiplied with x1
but
plus
3 times x bar, what is 3 times x bar?
That's okay. This will be just b.
Yeah, it will be just beta. So b is beta. Okay, so the first estimator, is it biased or unbiased?
It's unbiased. We are
Unbiased. Okay.
and it will be for n.
Yeah, because when you need to solve this problem for every n, you just replace between you replace the second class by dots 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 and 3 by n. Okay, nothing changes in the proof. Okay, so the first estimator, is it biased or not?
Unbiased.
Unbiased. Okay. Okay, let's check the second estimator. Once again, I strongly advise you to check for n equal to 3. When you understand what happens for n equal to 3, you can just replace the second plus with dots. Dot, dot, dot. So my advice, when you don't know how to deal with this sum xi, y, just write this term for n equal to 3. So
Oh, understood. What?
Второй является мы проверяем несмещенными. We check whether the estimator is unbiased. My advice is replace the sum by expression with plus, and second advice, take n equal to 3. So let's
I'm going to use the first or the second page.
Sorry, this is second.
I'm going to use
Yeah, n equal to 3. Yes, n equal to 3. So we just, the most simple case, take n equal to 3. Okay, let's write explicit formula for n equal to 3. No, x is small because it's non-random. So first, that's important to write big Y because Y is random. So that's important. Смотри, вот этот y он какой?
Большой.
Почему?
Потому
Да, а x он какой?
константы.
Он не случайный, non-random. О, вот так будем писать. Be very careful, because it's a hint what is random, what is non-random. Okay. Okay, yeah. And it's just this particular formula for n equal to 3. Then, the denominator, the whole denominator, is it constant or not?
Constant.
Constant. So we can take it out of expected value.
We can.
It also is.
Yeah. Yeah. The second one is also unbiased. Okay. But the formulas are clearly different. Okay. And so the question is, which one is better? So which one is better? So both are unbiased. So the main idea is to check which one is better. Okay. What criterion can we use?
MSE.
Yeah, MSE. So the problem is.
What about the consistency? Will we check it further?
Yeah, so we have only 3 minutes remaining, so basically we can check consistency of each estimator. How can we check consistency? First, so my idea, so MSE is just for you, because MSE is of beta hat is variance of beta hat plus expected value of beta hat minus beta squared. So this term is 0 because estimators are unbiased. So MSE, mean squared error, is just variance of beta hat. Okay? And how to calculate variance? You need to understand that x1, x2, x3 are constant or random? Constant. Beta x1 is constant or random? Constant. And what is random? Only epsilon. Yeah, only if you plug in. Okay, y is also random, but the source of randomness is epsilon. So, okay, when you calculate variance, you need to just remember x is constant, beta is constant, epsilon is random, and do this for n equal to 3. If you can do this for n equal to 3, then that's easy. If you need to calculate probability limit, you calculate the same thing, but you cannot work with n equal to 3. So if, let's say, calculate probability limit of beta 1, what is probability limit of beta 1? I will work with plus notation. So what is this? Y bar is the sum of y divided by n. X bar is the sum of x divided by n. First I remove n, okay? What I will have? I will have beta x1 plus epsilon 1 plus beta x2 plus epsilon 2 plus plus beta xn plus epsilon n divided by x1 plus x2 plus plus xn. Okay, first I replace, limit. I forgot limit here. Then I see that I can just divide first part by the second part. So I have beta times, so I have limit beta x1 plus xn divided by x1 plus xn plus limit epsilon 1 plus plus epsilon n divided by x1 plus xn. Okay? Yeah. This is just beta. And what is this? We know that each x is between 20, xi are between 20 and 100. So this sum is less than 100n, but it's greater than 20 times n, okay? So this sum is epsilon plus epsilon n divided by x1 plus xn is between epsilon 1 plus epsilon n divided by 100n, but less than sum of epsilon divided by 20n. Okay? Okay. Yeah? That is inequality. But we can say that probability limit of epsilon 1 plus epsilon n divided by n is that easy. You have law of large numbers, закон больших чисел, which says you that average goes to what? When you increase n, the average goes to expected value. Okay? So when you calculate the average of random variables goes to expected value. And what is the expected value?
0.
0. So this limit goes to 0. This limit goes to 0. So I have a bounded sequence from both sides. So this goes to 0. And basically we have proven that beta hat is consistent. The second beta hat is also consistent, you can do it. Okay, so your home assignment is so finish 25 up to the end, and you may start 26.1, 26.4. I think that's enough. And we will start with method of moments.
This